Hi everyone, this is me Manas. Hope you are all are well. Here in this video we are going to discuss about basic knowledge. You can say what basics are need to solve the problems of chapter 1 class 12, which is relation and function. In this video I assume that you don't know anything about relation and functions. That means we can start from 0. So, before starting, one request to all of you, please subscribe my channel, like the videos and hit the bell icons to get more such kind of videos. Also, if you like the video, then please share with your friends. So, don't wasting time, let start. Now, in these lessons we need to start from set. Okay, the basics of relations and function is what? Set. So, first of all we need to know what is set. So, set is a well defined collections of objects which we have already studied in class 11. So, let us take some small examples of set. Okay, that means let us take a set A. The set of prime ministers of India after independence. This is a set. Also, let us take an example B. The students of class 12 in your college. These are some basic small examples of set. Now, we need to know about types of set. Okay, basically there are four types of set. So, number one is finite set. So, this is nothing about, this is very simple. That means the if the element of a set is finite, that means countable, then that set is called finite set. That means these are examples of finite set where you can easily count the number of students in your class. You can easily count the number of prime minister after independence in our country. So, those number which you can easily count, that set are called what? Finite set. Number 2 is infinite set. So, in infinite set, the number of element in a set are uncountable. Let us take an example, the set of natural number. Okay. So, the set of natural number 1, 2, 3 is which is till infinite. This is uncountable set. This is an example of uncountable set. Similarly, set of integers, set of real number, these are all uncountable set. Three is number 3, empty set. So, this name is empty set. That means there is no any element in the set. It is denoted by phi. Okay, that means empty set the symbol of empty set is what? Phi. Okay. This is called empty set. That means there is no any element in this set. And 4 is singleton set. Here only one element in this set. Okay, let us take an example, set A, who has the element of letter A. Then this type of set is called what? Singleton set. That means if a set contain only a single element, then we call that set are what? Singleton set. Oh, one thing is that empty set is sometimes also called null set. After that, we need to know about subset. Okay. What? Subset. So subset is what? Let us take two set A. Let us suppose here the elements are 1, 2 and 5, and another set B who has contained the element, then this set A is called subset of B, because all the element of A are in set B. Okay. That means the definition of subset is, we can write like this way: set A is called subset of set B, which we can write like this way: if and only if each element of A are in set B. That means all the element of R A must be in the set B also. If there is a single element, let us take an example. Suppose here 7 is included in set A, then A is not a subset of B, because these 7 element are not in is not in present in set B. Hope you have understood easily. However, so we have get A is subset of B. That means all element of A are in B. Okay. Here the set B is called what? B is called superset of set A. Name of B is what? Superset of set A. Now one note: if A is subset of B, but B not equal to A, then A is called proper subset of B. Subset of B, which we can write like this way. That means, what is the example? What is here I want to explain you, that is, if A is 1, 2 and B is 1, 2, 3, then A is a proper subset of B, because here A and B are not equal. If A is also 1, 2, 3 and B is also 1, 2, 3, then A is a subset of B, because each element of A are in B, but this is not a proper subset. because A equal to B. Remember. Next is number of subsets and number of proper subsets of a set. So, in a set, if there is 3 element, then how many subset will be getting and how many proper subset will be getting. So, look here, let A be a set with n element. Okay. That means the value of n here 3, the value of n here 2. Okay. Then number 1, the number of subsets is 2 raised to power n. That means if A equal to A, B, C, these are 3 element, then total number of subsets of A is 2 cube, because here element number of element is 3. So, value of n is 3, 2 raised to power cube is equal to 8. How this is? Look here. Remember, phi is always subset of another set. Okay. Then this is a subset of A, this is also subset of A, this is also subset of A, this is a subset of A, this is a subset of A, this is a subset of A as well, this is also a subset of A. Now count this value 1, 2, 3, 4, 5, 6, 7, 8. So, except this, we do not get another subset of this set. So, it is easy to find out number of subsets. Also, if you subtract 1 from total number of subset, you can easily get the total number of proper subset. Okay, because proper subset, this is not a proper subset. So, only one subset which is not a proper subset. So, we can subtract from this to -1, then we will be getting the total number of what? Proper subset. And now coming to next definition. Definition is what? Power set. What is called power set? Power set is the collection of all subset of set A. Power set is a collection of all subsets of set A. That means, if we take here one bracket, then this set of proper set of subset is called power set of, which is indicated like this way. Power set means set of all subsets. That means set of all subsets of a set is called power set. I think you have understood. My definitions are very easy. We have used here very easy and simple definitions for your understanding. Next, another one thing we have need to know, which is called universal set. Universal set. So, what is the definition of universal set? A set that contains all the elements under consideration. In a given problems is called universal set, which is denoted by U or sometime S. So, take an example for understanding universal set. Let us set A, suppose there are some month March, April, September, etc. And then universal is U is what? Month of the year. Okay. So, if we take a set of natural number, then universal set is what? Please find out it yourself. Please give the answer in comment. Okay. Next is what? Complement of a set. Complement of a set. This is very easy. Let us suppose U 1, 2, 3, 4, 5 and take a set B which is 1, 3, 5, then B complement symbol is like this way. Okay, we can represent it by dash, then B complement is U minus B, that means what? 2 and 4. This is called complement of that set. Okay. Now we are on the way to our main topics, which is what? Relation. So, before relations we need to know what? Ordered pair. Ordered pair. What is called ordered pair? So, if a pair of elements is written in a specific order, then such a pair is called an ordered pair. Clearly A comma B not equal to B comma A. Now going to explain these definitions. So, basically this is what the ordered pairs A comma B of element A belongs to set A and B belongs to set B. That means there are two sets A and B. Is called Cartesian product of set A and set B. So, ordered pair come from Cartesian product of two sets. So, now we need to know what is Cartesian product. Okay. So, let A and B be two sets. Now, set consisting of all ordered pairs A comma B, where A belongs to A and B belongs to B, is called the Cartesian product of the set A and B. It is denoted by A cross B. So, this is what, look here, let us take an example for understanding these definitions. Let us suppose A is equal to A, B, C and B is 1 comma 2. This set we can represent like this way: A, B, C, this is called A and this is B 1 comma 2. Then the relation from A to 1, A to 2, B to 1, B to 2, C to 1, C to 2. These are called what? Cartesian product. So, if we write A cross B, then this is become A comma 1, A comma 2, B comma 1, B comma 2, C comma 1, C comma 2. These are called what? Cartesian product of set A cross B. But if we take B cross A, then what we will be getting? We will be getting 1 comma A, 1 comma B, 1 comma C, 2 comma A, 2 comma B, 2 comma C. Clearly, it is feasible that these are not equal to these are, because here 1 comma A is present, but here A comma 1 is present. So, these are not equal. So, you can say A cross B is not equal to what? B cross A. Now, if we understood the definitions of ordered pair and Cartesian product, then we come to move our next topic, what? Relation. Okay. So, relation is nothing. So, relation is what? Let us take some example. Suppose A and B are two subset of a set of integers. A is subset of integers and B is also subset of integers. Integers we can represent I or Z. We are taking two subset A and B, which are set of integers. For some element x belongs to A and y belongs to B, let us take an conditions, which is condition is what? X is less than y. So, here less than is relations with x and y, like the relations you and your mother. Okay. you and your father. Let us suppose there are two brothers and sisters, A and B. These are brothers and sisters. Then suppose X and Y are their parents. Then A related to X with X is mother and Y is father. Then A is also related to X and A is also related to Y. Let us suppose A is son and B is what? Daughter. So A is related to X with relations mother, and A is related to Y with relations father, and similarly Y is related to A as a son and M is also related to A as a son. Similarly X is related to B as a daughter and Y is related to B as a what? Father. So these are some basic concept of relations. So here the less than symbol is also a relations. So we can say X plus Y is also a relations which we call a binary operations. Okay. So these are a simple relation which is X is less than Y. Then suppose A is what? 1, 2, 3, 4 and B is, let us suppose 2, 4, 5, 7. Then how many ordered pairs come from the Cartesian product A cross B which satisfies this condition? That means X less than Y. So we can take 1, 2, 1, 4, 1, 5, 1, 7, but we can't get 2, 2 because 2 is not less than by 2, it is equal. So this element here not comes. Similarly 3, 2 is also not come here because 3 is greater than by 2. We have need only less than amount. So we can write 2, 4, 2, 5, 2, 7. Similarly 3, 4, 3, 5, 3, 7. So these are basic concept of relation. So now we can write the definitions of relations. The definition is what? If A and B be two non-empty set, then a relation R from A to B is a subset of A cross B. That is, relation R is a subset of A cross B. This can be represented like this also. R such from A to R is a relations from A to B. So here simple one of the simple examples. This 1, 2 and 2, 3. There is a relation R which is X minus Y is equal to 0, where X belongs to A, Y belongs to B. Then here we will be getting only one ordered pair which is 2, 2. So this is a subset of Cartesian product of A cross B, because in A cross B what we will be getting? A cross B will be getting 1, 2, 1, 3, 2, 2, 2, 3. So here 2, 2 is present. So this is a proper subset of A cross B. Now we have need to know types of relation. What? types of relations. So, first empty relation. Okay. So, if there is no any relation between the elements of a set or set, then the relation is called empty set, not empty set, empty relation. Okay, that means there is no any relation. So, take an example, A is 1, 2, 3, and relation are from A to A, which is what? A square is equal to B. That means the Cartesian product of A cross A, here Cartesian products are what? 1, 2, 1, 1, 1, 2, 1, 3, 2, 1, 2, 2, 2, 3, 3, 1, 3, 2, 3, 3. But here we don't get any cross product, any ordered pair in the cross product which satisfied these relations. A square is equal to B. That means we can't get any value that if we square, that value is are again in set A. That means if there is an element 4 exists, then we get a relations 2, 4, because 2 square is equal to what? 4. Okay. So, this is an empty relation, since there is no any such kind of elements are exist. Next is identity, next is reflexive relations. So, this is very important. Reflexive relation. Now, look here everyone, a relation R on a set A is called reflexive if and only if every element of A are related to itself. So, that means R is reflexive if for all A belongs to A comma A belongs to what? R. Take an example, suppose A is 1, 2, 3, then R is a relation that 1, 1, 2, 2 and 3, 3 which is exist, then we call that relation is what? Reflexive relations. That means same element related with same element. Okay. Symmetric relation. a relation R on a set A is said to be symmetric relation if A comma B belongs to R. This implies B comma A are also belongs to R for all, not for all, for A comma B belongs to A. Take an example. Suppose A is equal to 2 comma 4 comma 7, then a relation R 2 comma 4 4 comma 2 7 comma 7. This is symmetric relation because 2 comma 4 is exist, so 4 comma 2 is also exist, 7 comma 7 is also exist. Here reflexive relation is also exist because 7 comma 7, that means you can say that reflexive relation is also symmetric relations. Okay, reflexive relation is also a symmetric relations. Remember that reflexive relation is also a symmetric relation because A comma A and A comma A both are in that reflexive relation. So, all reflexive relations are symmetric relations. So, this is a symmetric relation. Remember that in reflexives all elements are need to related itself. That means here not to need all the elements of set A are formed A comma B. This implies B comma A relations. That means 2 comma 2, 4 comma 4, 7 comma 7 are not to need exist all the things. Whatever exists in that set, that are also that elements only need to satisfy these conditions. The others element not to need to satisfy these conditions in case of symmetric relation. And next is transitive relation. So, transitive is also very easy. This is what, if A comma B belongs to R and B comma C belongs to R, then if A comma C belongs to A comma C also belongs to R, then we call that relation is transitive relations. That means for a set A, two comma 4 comma 7 relation R equal to 2 comma 4 4 comma 7 7 2 comma 7 and 4 comma 4 is transitive relations. Why? Because here 2 comma 4 is exist, 4 comma 7 is also exist. So, here this is A, this is B, this is B, this is C. A comma C, this is A comma C is also exist. So, this relation is a transitive relation. Next is equivalent relations. Equivalence relation. So, it is a mixture of three relations: reflexive relations, symmetric relations, and transitive relations. So, what is equivalent relations? A relation R is called equivalence relations if R is reflexive, symmetric, and transitive. So, my dear friends, we will continue our this series by one videos. So, today I have shown that here I want to close our video lectures, because you have need to study what we have learned. After that, we will be learning the later parts. That means here we will be discussing congruent modulo and equivalent class. After that, we will be going to learn about functions. Okay. So, thank you again for watching my video. Please support my channel to subscribing and giving your valuable time to watching my videos. If you will be getting any confusions, please write in my mail address, which will be given in my channel. Also, please follow my telegrams, which links is given below. Thank you everyone. Thank you.